Junior, this is for you, my boy. This is what you were asking for. So Daddy is doing this video for you and also others who can learn from it. So I'm going to do composite numbers and prime numbers. All right, but I'm going to do a few more things there, joining the two. I'm going to do things like multiples and factors a little bit. All right, so let me look at what you know. You know that 7 times 2 is 14. You know that 5 times 4 is 20. You know that 4 times 8 is 32. Let me bring one. So if you know multiplication, especially this basic multiplication of one digit times one digit numbers, you should also know the reverse of multiplication. And do you know what is the reverse of multiplication? Yes, of course, it's division. Now, so if you look at here, at this 14 here, and you divide it by 2, you get 7. And the same if you divide 14 by 7, you get 2. The same applies with this 20 here. You divide this 20 by 5, you get 4. You divide this 20 by 4, you get 5. The same applies for 32. 32 divided by 4 gives you 8. And 32 divided by 8 gives you 4. All right, so we call the 14 and the 20 and the 32 the multiples, okay, of 7. So 7 times 2 gives you 14. Or 14 is also a multiple of 2. If you do the 2 times table, 2 times 7, you will get to 14. The same, for example, with 20 here is a multiple of 5 and also a multiple of 4. All right. So if you multiply 5 times 4, you get 20. And the same 4 times 5. All right. So what do we call the 7 and the 2? Remember, when you multiply, the answer is the product. But what do we call the 7 and the 2? These numbers, they are going into the number without leaving a remainder. They are what we refer to as factors. All right. So let us talk briefly about factors, and I want to see if you know the factors of the following numbers. Okay, let's take 21 for example. So these are all the numbers that go into 21. All right, so you should know that they are finite. It means there are only a certain amount of numbers that go into 21. You can't have numbers, infinite numbers. All right. So the factors of 21 is 1, 3, 7, and 21. Okay. So if you got that right, you're on the right path. Now, how many factors does 21 have? Well, you counted them. There are 4. Let's talk about 15. Right, so what are the factors? What are the numbers that go into 15 without leaving a remainder? Of course, if you said 1, 3, 5, and 15. Right, so how many factors does 15 have? So it has got, that's correct, 4 factors. All right, let's take one more, 81. So how many factors does 81 consist of? Yes, of course, 81 has got 4 numbers that go in 81. Okay, and the factors of 81 is 1, 3, 9, 27, and 81. What about 31? It's a rather odd looking number. So 31 only has 2 numbers that go into it. All right, only 2 numbers can go into 31. The same applies with 43. Only 2 numbers go into 43. All right, so I have made this a little bit light blue for a reason. So you have to think about numbers that only have 2 factors, and these other numbers here, they have got more than 2 factors. Let's talk about the number 1. Well, this is a special kind of lonely number, right? It has only one number that goes into it. So when we talk about composite numbers and when we talk about prime numbers, 1 is not included in that scenario. It's a special number, okay? Because it only has itself. So it's kind of lonely, all right? But it's still a very important number. So multiples as opposed to factors. You see when you did the factors of 21, for example, you realize that 21 has only a certain amount of factors. We say it got finite factors. Okay, it cannot have more. all right? There are only so many factors that go into a number. But multiplication is the other way around. The multiples of numbers never end. So if I was to ask you to find or to say all the multiples of 5, you will realize that you will never end. That will be 5 times 1 is 5, 5 times 2 is 10, and it go on and on and on because multiplication never ends. That is why when you are doing the lowest common multiple between two numbers, you are supposed to find the lowest common one. But I will do that on another occasion. All right, let's talk about interesting factors and some interesting multiples that I just want to bring to your attention. Let's talk about here. I have the 3 times table, so I took a few of them. So you have 3 times 4 is 12, 3 times 5 is 15, and so on and so on. Okay, so later on, I will definitely also show you how to do mental mathematics, where you can multiply a number easily without having to resort to grabbing a calculator. For example, if you were to take the number 3 and you multiply it by 14, okay, so the answer here will be 30 plus 12. Okay, so this answer here will be obviously giving you an answer of 42. Right, so you get to this and you see I multiply from the right to the left. All right, so what I'm doing here, the number 14 in my eyes is nothing but 10 plus 4. Okay, so when I multiply this by 3, and this is the most important part. So in my mind, I first multiply, okay, I multiply 3 times 10. And then 3 times 10 gives you 30. And I add that with 3 times the 4 there. And 3 times 4 is where I get the 12. All right? And I simply add those two, and then I get to the answer. So, let me do a few more, but this is not the objective of that lesson. The lesson here is simply to focus on a few things like factors and multiples and composite numbers. All right, but let me just bring in one more so that you can see that this is a very vital art that you need to be able to master. So let's take the number 4 and we multiply 4. Let's say multiply 4 by 21. Right, so the answer is, remember what I said, you must view 21 as nothing but 20 plus 1, because that is what it is basically. So I have got 4 times 20, okay, which I know is 80, all right, and then I have got 4 times 1, which I know is what? Is 4. So I know that this answer is 84, all right. So if I have to do multiplication of numbers, I work from the right, okay? But it needs practice. So you need to do a lot of practice. So this is 6 times, let's suppose it's 6 times 13. So what I have here is 78 as an answer. So you see, while I'm talking, I'm actually getting to calculate, all right? So I know that it's 60, which comes from the 10, all right? And then 6 times 3 gives me the 18. So you can actually do this type of multiplication once you are exposed to mental mathematics. But this is not what I'm focusing on. I want to focus on perhaps you have come across this, what we refer to as divisibility by 3. That means we are checking whether a number is divisible by 3 without having to do long division or any of the sort. Right? So when you look at the number here, the 12, the product, and if you add 1 plus 2, you realize you get 3, all right? The same applies when you add 1 plus 5, you get a 6, 1 plus 8, you get 9, 2 plus 1, you get a 3, 2 plus 4, you get a 6, 2 plus 7 gives you 9, 3 plus 0 gives you 3, and 7 plus 2 give you 9. So when you look at those numbers that I have here in red, you will see that these numbers in red are all numbers that 3 can go into. They are divisible by 3. So when you add a number, all right, any number, and you want to make sure whether 3 can go in that number. Like for example, I have the number 729 that I have showed you here. If I add the digits of 729 and I say 7 plus 2, which is 9, and 9 plus 9 is 18. Then I know that 3 will go in this number without leaving a remainder. So that is one of the things you can do when you want to check for what we call divisibility by 3. There are others. There's divisibility by 9 that is similar, but I'm not going to get into those. Another interesting multiplication times table I want to bring to you is the 11 times table. So when you look at the 11 times table, and I have worked out a few here, all right, you will realize that the numbers in red that you see there, right, they are nothing but an addition. They are a sum of the two numbers that are flanking it. You see, if you take the 1 on the outside plus the 2, that gives you 3. If you take the 2 plus the 5, that gives you 7. If you get a 2 plus a 3, that gives you 5. And 4 plus 4, that gives you 8. So if I was to take, let's say, a number like 11, let's say I say 11 times, let's suppose we say 11 times what, 21. All right, so what I have here is I'll take the 2 and I'll take the 1. The 2 and the 1 that you see there are actually this 2 that is here, all right, and obviously also the other one is the 1 that you see. It's this one that is here. So you split it kind of like that, and then you simply now add these two numbers. When you add, you get 231, and this is basically the answer to 11 times 21. So the 11 times table is very interesting, but I will show you exactly what you do whenever you get to a number that when you add, you get more than 10. Okay? Right, so that is exactly what I have tried to explain to you there, where I get the numbers in red. Okay, you just add the sum of the digits, the 1 plus 2, and then you split them. 1 plus 2, you split. 8 plus 1, you split. They put the number in the middle. Right, so here I have 11 times 75. Now, when you multiply 11 times 75, right, remember what I said, you add the digits, all right? So, but before I add the digits, I am also going to split. So I split the 7 and the 5 like this, okay? So somewhere on the side now, on the side, you are going to add now. When you add 7 plus 5, for example, all right, that gives you 12. But the way I'm going to write this 12, I'm going to write the 2 here and the 1 here because I'm carrying it over. So it's going to be 825. That is how you will be solving this particular question. Okay, so just remember that when you are adding and it's more than 10, you must carry over that 10. Okay, and then you add to the 7, as you can see. Let's take another one. All right, let's take 11 times 93. All right, so you will have to pause the video and you will do quite a few more and to see if you can get to the answer. So I'm giving you time to try this one quickly. So let me see if you have got it right. So I'm taking 11 times 93. Okay, so what I'm going to do, remember, I said very simple step. I take the 9 and I take the 3 and I split them. Okay, like that. So I'm going to have something in the middle. So what I have in the middle is I'm going to take the 9 and I'm going to add the 3 here. Now when you add 9 plus 3, you get 12. All right, so I'm going to put the 2 in the middle and I'm going to carry over that one here. So I'm going to 1023, and this is the answer that I'm getting when I multiply 11 times 93. Okay, so you must practice, and you will realize as you practice more, try more numbers. Later on, I'll show you how to do even 3-digit numbers and even 4-digit numbers when you multiply by 11. So I have 1 here, 11 times 27. In yellow, I split, and then I add the 2 plus 7. That gives me that 9 that you see in the middle there. All right, let's talk about prime numbers. Now, prime numbers are numbers that only have two factors, okay? There are only two numbers that go in it. So I have listed a few here, all right, and they also never end. So 2, 3, 5, 7, 11, all these numbers, they are prime. Now, before you answer this question, let's just briefly write down. So if I write down the numbers that can go into 2, for example, it's only 1, and the number itself. If I write 23, all right, it's only 1 and 23 that will go in this number, okay? So if you write 11, it's only 1 and 11 that goes into the number. So when you do prime numbers, you would realize that they only have exactly two factors, numbers that go into it without leaving a remainder. Okay, but now I have written down a few here, and I want you to see whether these numbers are prime. So I'm going to give you an opportunity, all right? You can pause the video and then you can try to see if these numbers are prime. You don't do any type of long calculation or whatsoever. So the number is 91, and the other one is 57, and the other one is 100. Right, so if you have listened to what I have said about checking for 3, then you will realize, okay, this one here will not work if you are adding the digits, because you're not going to get a multiple of 3. So I'm going to come back to this one. But if I check 5 and 7, if I add 5 and the 7 for 57, I get 12. So therefore, this number here, yeah, it is not a prime number. Okay, it is a composite number. It has got more than two factors. What about 111? If you add 1 plus 1, that gives you 3, and surely 3 can go into 3. All right, so because 3 can go into 3, then it means then this number here is also not a prime number, because 3 can go into it. But here's the thing about 91, and I purposely will put it here. All right, 91 requires you to know your times table. All right, so if you go on the 13 times table, all right, you will realize that it is not. So sometimes you have to go out a little bit, all right, but you do not memorize this. So what you do is you take 91 and you start with the first prime number, all right. In this particular case, the 2 would not go in there, the 3 would not go in there, the 5 would not go in there without leaving a remainder. So I will be using then the 7. So you list the numbers here and you ask yourself how many times the 7 go there. Obviously you realize the 7 goes there 13 times, and then 13 goes here once. So if you realize that a number looks kind of odd and funny to you, not all odd numbers, remember, are prime. Okay, so do not just look at an odd number and say, oh, they are prime. The first prime number, however, the very first prime number is definitely not odd. The very first prime number is nothing but the number 2, and it's the only number that is even in all of the set of prime numbers. But not all odd numbers that you find, okay, are prime. So because when you are talking about prime numbers, all of the prime numbers are odd except the very first one, okay? But not all odd numbers are prime. Now remember, odd numbers are numbers that end with, okay? So when you want to know an odd number, ends with a 1, it ends with a 3, it ends with a 5, it ends with a 7, and it ends with a 9. Numbers that end with this, they are odd, but not all odd numbers are prime numbers. Okay, so you have to be a bit careful that you do not assume when you get a question, then you say, oh, this number looks funny and therefore it is odd. All right, so don't make that mistake. So I believe that you also do prime factorization, where you take a number and you list it as a product of its prime factors. Right, so let me bring in composite numbers here. Now, composite numbers is the opposite of what prime numbers are. They just have got more than two factors, okay? But remember I said 1 is a very special number. 1 only has 1 that goes into it. So all these other numbers here, right, they are composite numbers. That means they have got more than two factors. So if you look at number 9, 1 goes there, 3 goes there, as well as 9. Can you see that you have got 3 factors there? All right, so therefore this number is not a prime number, but it is a composite number. 1 goes into 15, 3 goes into 15, 5 goes into 15, as well as 15 in itself. All right, so you see it has got more than two factors, right? I already talked about 91. 1 goes there, obviously, 7 goes there, and 13 goes there, as well as 91. All right, so also 91 is not a prime number. And lastly, 36 is 1 go there, 2 goes there, 3 goes there, 4 goes in 36, 6 goes there, all right, 9 goes there, 12 goes in 36, as well as 36 itself. All right, so there's actually one more that I have left out, so let me just bring in that one that I have left out. Half of 36 is 18, and 18 also goes into 36, and also 36 itself. Right, so on another occasion I will explain to you how you can check whether your factors are exactly enough that you have listed. So what I have here is a kind of a serve, and we use a serve, right, when we want to take out things that we don't want. So I have a table here, and I would ask you to do the same, maybe from 1 up to 100. And when you do the table from 1 up to 100, you must be left with, I'll tell you exactly towards the end of the video, which is going to be any time now, how many numbers you should have left. So I know 1 is not a prime number, so I'm removing it then. So I'm going to be left on my table with only prime numbers. I also know that 4 is not a prime number. Remember, 2 is a prime number. Only 1 and 2 go into 2, and only 1 and 3 go into 3 without leaving a remainder, and so on. So 6 is not a prime number, so I'm removing it again. 8 is also not a prime number. 9, we have seen in the previous slide, is also not a prime number, but I can start removing 10. The next one is 12. The next one is 14. The next one is 15. 16 is not a prime number. 18 is not a prime number. 20 is not a prime number. 21, remember, 2 plus 1 is 3. 3 goes there. All right, already 1, 3, 21, 7, so it's not a prime number. 22 is not a prime number. 24 is not a prime number, as well as 25. So these, what I have left, are prime numbers. So they are prime numbers, and I know that prime numbers, remember, they are exactly numbers that have got two factors. So what you do is you are going to do a table like this one. All right, that's prime numbers. A table like this one, and then you're going to go on 6, 7, 8 up to 100. So you're going to have a 10 by 10 grid. Okay, so when you make your grid 10 by 10 grid, all right, so you have got 10 by 10 grid. So you start from 1 up to 10, and then you start from 91 here up to 100 in the blocks like I did in these tables here. And then you are going to do the same, remove the numbers that are not prime. Okay, and once you have done that, you should, and I will tell you exactly now, you should have the numbers that are prime that you have left. All right, they should be altogether between 1 and 100. Between 1 and 100, you should have 25 prime numbers. All right, so when you do this, you can do this in your book on your own. You must find 25 prime numbers once you do this for a table from between 1 and 100. So when you do a table between 1 and 100, you should have 25 that are left. Right, so I have done this, I hope that somehow you are not confused. Maybe you can go back, check the video again, and then you see whether everything else is making sense. All right, so if I have to repeat this so you can see. So if I remove numbers that are not prime. So when you do your table, you are going to do your table from 1 up to 100. So 1 to 10 in one row, 11 to 20 in another row, and until 100, and then you remove the numbers that are not prime. Once you remove the numbers that are not prime, then you should be left with prime numbers only, all right? And the prime numbers should be 25. So here, I only did numbers between 1, okay? I only did numbers between 1 and 25, and I realized that the numbers between 1 and 25 that I have is 1, 2, 3, 4, 5, 6, 7, 8, 9 prime numbers, okay? So when you do a whole table all the way up to 100, then you should have 25. See if you are working it out, see if you are getting it, and if you get them, then you are on the right path.